This video is an introduction to using tree diagrams to solve probability problems involving multiple events. I will go through two examples in detail. Let's look at the first one now. Okay, our first example says, in Verona, when it snows at least 4 inches, they close the schools 80% of the time. When it snows less than 4 inches, they close the schools 15% of the time. 30% of snowfalls are at least 4 inches. So that's a lot of information contained in those few sentences. So before we even go to answer the question, let's draw a tree diagram to represent this situation. So schools being closed is based on how much it snows. So our first branches of our tree diagram are going to be those that relate to it snowing. So you can see I've drawn in my two branches, and my two options for snowing were either it snows greater than or equal to 4 inches or it snows less than 4 inches. So this is the first thing that has to happen in this scenario. It snows. Now, if it snows greater than or equal to 4 inches, we have some information about school being closed. And if it's less than 4 inches, we have some information about school being closed. So we now need to draw two more sets of branches to represent school being closed or not in each of these scenarios. So I'll draw those now. Okay, so these sets of branches represent school being either closed or open. Now we need to fill in the different probabilities. I could have done that for the snowing more and less than 4 inches before drawing these, but I'll just do them all now. So we're told that 30% of snowfalls are at least 4 inches. So that's here. Greater than or equal to 4 inches. That's 30%. So up here, I can either fill in percents or I'm actually going to use the decimal equivalent. So if that's 30%, then that means the rest of the snowfalls are less than 4 inches. And together, these two probabilities must add up to 100% or 1. Because these are my only options when it snows. It's either going to do more than 4 inches or not. So since these two things must add up to 100% or 1, my missing probability must be 0.7. Now I'll fill in the information about school being closed or open. So our first sentence says, when it snows at least 4 inches, which is this branch here, they close the schools 80% of the time. So closed is going to be 80% or 0.8, which means this is going to be 0.2. Then it tells us that when it snows less than 4 inches, which is this branch here, they close the schools only 15% of the time, which means they're open the rest of the time, which if this is 15%, this must be 85%. So I'll fill in those decimals now. Now that I have a completed tree diagram, I can worry about the question, which was, what's the probability they close the schools when it snows? Okay, this can happen in two different ways. You'll notice if we look at the bottom of our branches here, school can be closed this way or school can be closed this way. So listen to the words carefully. It can either snow more than 4 inches and they close school. So those are multiple events that have to happen. Or it can snow less than 4 inches and they close school. So let me write that up in terms of probability notation. So I have here what I just said, which is it can either snow more than 4 inches and they close schools, or it snows less than 4 inches and they close schools. So since multiple things have to happen here, or multiple events, I'm going to use multiplication. And then either this scenario or this scenario can happen. And if you remember, when we say or, when we're dealing with probability, we add. After doing out the calculation, you can see that there's a 34.5% chance that they will close the schools when it snows. I'd now like to do this same problem set up in a table just to show you that there's another way in which you can represent this information. The data that's going to be in the table is going to come from following each of these branches down to the end. There are 4 different scenarios that can happen here. It snows more than 4 inches and schools are closed. That probability would be 0.3 times 0.8, which is 0.24. It could snow more than 4 inches and school is open. That would be 0.3 times 0.2, which is 0.06. It could snow less than 4 inches and they still close schools. That would be 0.7 times 0.15, which is 0.105. And finally, it could snow less than 4 inches and school is open, which would be 0.7 times 0.85, which is 0.595. Now remember, those 4 scenarios together are all the possibilities when it snows. So these values that I came up with at the bottom where I did the multiplication, those 4 values that I calculated should add up to 1 or 100% again. We'll see those values in the table on the next slide. So here's the table. You'll see the 4 numbers that I read out following the 4 different scenarios represented in the tree diagram. You'll also see that it snows more than or equal to 4 inches 30% of the time, if I follow that down, and less than 4 inches the rest of the time, 0.7 or 70% of the time. Here's our answer from the previous question. School could be closed in 2 different ways, when it snows less than 4 inches and when it snows more than 4 inches. So that answer, school being closed, is here. School being not closed would be here. Okay, so here we've already done some multiplication to get these values in the table, which I showed on the tree diagram. So if you remember when we talked about tables previously, I told you that you wouldn't have to do multiplication. Here, I can see the result for when school is closed and it snowed less than 4 inches. That's right here. So again, multiple events happened to get this value. It snowed less than 4 inches and they closed school. One other thing I wanted to point out is that your options over here have to add up to 1 or 100%. School is either closed or it's not. And it either snowed less than 4 inches or it didn't. So all of these have to add up to 1 or 100% as well. Let's look at one more example. I took this example from our textbook. So it says, bag A contains 3 red balls and 3 blue balls. Bag B contains 1 red ball and 3 blue balls. A ball is taken at random from bag A and placed in bag B. A ball is then chosen from bag B. What is the probability that the ball taken from B is red? So at first, this might seem overwhelming, but by making a tree diagram, we'll be able to represent this information easily. So the first thing that happens is that a ball is taken from bag A. So that's going to be the first branches for my tree diagram. So here are the branches for bag A. Half the balls are red and half the balls are blue. So first we're going to take a ball out of bag A. We're either going to choose a red ball or we're going to choose a blue ball. We're then going to put that ball into bag B. So this is saying I choose a red ball. I have a 50% chance of doing that. And so now I have to draw bag B. And bag B will have a red ball from bag A in it. And over here, this is if I choose a blue ball. And so then down here with bag B, I'll be putting that blue ball into bag B. Okay, so here is bag B. I'm either going to take a red ball from bag A and put it into bag B, or I'm going to take a blue ball and put it into bag B. Bag B already has 1 red ball in it and 3 blue balls. So this is saying that I take a red out of bag A and put it in here. So now I have 2 red balls in bag B and still the 3 blue balls. So now my probability of getting a red out of bag B is 2 out of 5, and for getting a blue is 3 out of 5. This branch is saying I take a blue out of bag A, which is going to affect down here. Now there will be 4 blue balls in bag B and just 1 red ball. So I'll fill those in now. Now my tree diagram is complete, and the question asks, what is the probability that the ball taken from B is red? So here's bag B. These are all the possibilities that can happen. So I can get a red following this scenario. I can also get a red following this scenario. So listen again carefully to the words. I can take a red ball out of bag A and then get a red ball out of bag B, or I could take a blue ball out of bag A and then still get a red ball out of bag B. So I'm going to write that up using probability notation. So this is representing the probability that I get a red out of bag A. I put it into bag B and then I get a red out of bag B. So that's a red and then a red. Or I get a blue from bag A and I put it into bag B and then I still choose a red. You can see my calculation down here, and when I do out this math, I get 3/10, which is 30%. And so that is the probability that the ball taken from B is red. I know some of these tree diagrams are tricky, but with practice, you will get better at them. So just hang in there and do your best. I hope this video was helpful.